Now next in this question is line reflection. So it's medium level question and the it's premium question, right? Now you can see the Google and the other company also asked this question recently. And then here also say follow up. Could you do better than length n square? Okay. Now we need to here you can see this one is our input. The output is true because we can choose the line x equal to 0 and to make these 2 point equal, right? So now let's go through how to find the line to make those point equal. So for example, the first example is -1 and the 1. So you don't need to care about the coordination here. It doesn't matter. So now, so the key point is the x. We need to get is the x. So we need to find the minimum and the maximum x. So now we know because here just only 2 point, right? So it's really easy to see. Is we know we can choose this line, right, to make these 2 point equal. So how to do that? Uh, you can see we need to get the minimum. So okay, minimum is -1 and the maximum is 1. Now we just sum up the minimum and the maximum. So we got a 0. When we got a 0, which means and then we also need two second data structure here. So we need the set. We need to go through the point array and then we need to store each the xy into the set because they will easy to check if the reflected point present in the set or not. So that's why we need a set can quickly check, right? So here, okay, we know is sum equal to 0. So now we need to go through the first step. We need to go through the array and then looking for the minimum and maximum, and then putting xy into the set. The second step is we need to go through the point array one more time, and then, for example, okay, we go through this point. Okay, we get this x, the x -1 because here already -1, right? Minus minus -1 here should be become 1, right? So now here should be 1. The 1 is the refractive point. So now we need to use this one with the y, original y, put it in the set. We need to check the current 1 and the 1. No, the y is the original y. The y is from the current x minus the sum to get a new x. Now, because we reflect the point, now we need to check, do we have another point in here? We need to check the current reflect point in the cell or not? If yes, so we know, you can see here, this one, let me remove the, so we know we got a new point. We know here equal to here, right? So now we got this one. So we need to check the set. We know this the point already in the set, right? So now when we get this, okay, we know. So because we use the here to get the point, and then to check the set have this one or not. Yes, here say yes, right? Because we first step we just go through the point array and store each point into the set, right? Then so we can find the point present in the set. We can say, okay, this point have the line reflection, right? So we just return a true. So we just use this way to find. Now we put in a second example. Now here let me remove this one. And then you can see the second example is the -1, -1. Okay. So now it's -1 and -1. So the first day we put the each point into the set. So these 2 points we store in the set, and then we also need to find the minimum x and the maximum x, right? So now it's -1, it's 1, still the same. Now we need to sum up minimum and the maximum. Now here's sum equal to 0. Now we need to go through this 2 point one more time. So now we use this x to minus the sum. We know minus with the -1. So here become a 1, right? So now it's the reflex x. So now we need to use the 1. We need here become 1. 1 with the x -1. And now we need to go through the set. Do we have the 1 -1 in our set? Definitely no, right? We couldn't find this new point in our set. Actually, we need to find the reflected point. But here, that I have the reflected point, right? Because the point is in here. But we know the second example, we need 2 points. The second point in here, but we got a new points in this here. So now we couldn't find this one in our set, so which means we need to return a 4. So same thing. Now we will go to here. So here we had 2 points, right? Now we finished the first point. Now we need to check the second point. It's same thing, right? If this one couldn't find any reflect point, so no matter how we do for this one, still not getting a reflected point, right? So now let's start this question, and then we have the set. Now new set. Now we have minimum, so integer dot maximum, and maximum equal to the minimum value, right? So now we need to go through the point. So now here we need to mean the p dot I 0 and maximum. Now next step we need to here, okay. Now we need to p o plus. So we can put anything here, and then p and 1. Now here we need to get a sum minimum plus maximum, and then next step we need to go through p the points, right? Now here we need to get number in p sum minus. So now we need to check the set contain nouns plus the column between the xy, the p and the 1 return 4, right? So here should be not contained. Otherwise, if at least 1 point cannot find the reflex point, as here we just return 4. Otherwise, we return true, right? So you can see is pass on the test case. Now let's submit it. Okay, even though it's just 30%, now let's analyze. So the time complexity is b of n, right? And then here we also use the set to store each point. So I would say the space complexity complexity is b of n here. Yeah, because we need to store each point in a set into set, right? So now thank you watching this video.